So hello everyone. So my name is Jonas. I am a senior software engineer at Postman, working on AsyncAPI in the open technologies teams that you just heard a little bit about from Fran. Um, Now, just a quick backstory on me. I started back in 2019 contributing to AsyncAPI because I had a free time project that naturally needed this specification, and especially the tooling, because I wanted to automate as much as my coding as possible. Now, at the core of all toolsets, all toolboxes, we have a parser. We want developers to be able to parse async API documents, as well as validating those documents, and providing a way for developers to interact with the document. So this means that by interaction, I mean accessing certain information within the document itself, as well as traversing over, for example, channels, messages, components, whatever is in the specification. At the moment, we have a JavaScript parser that is our main parser, that is our main focus point. We also have a Go parser. It's currently still work in progress, but this is just to emphasize also that even though that we only support JavaScript and Go parsers at the moment, like it all depends on your use case and what you as a developer need. And you are most likely not the only one if you ever think that you need a specific parser in a specific language, and that's where collaboration starts. A pain point that frequently come up when you talk about supporting different parsers in different languages is that you want to make sure that each parser is compatible with the spec, which is why that we have our test compatibility kit that ensures it's basically just a collection of different combinations of the async API specification, different combination of messages, headers, channels, servers that should be supported and be valid or invalidated by the parsers and validators. Something I did not include in the slides, but I just want to quickly mention is that we have been, or a pain point that also comes up is, or with parsers, is that it's highly coupled together with the specification, meaning that if the specification changes versions or changes structure in any way, it affects the tooling, and the tooling have to adapt to it. So we are currently looking into ways that we can remove this coupling between the specification and the part or the tooling by taking a more general approach to structure it based on event-driven architecture in general. But it's still a work in progress, but it is a pain point we are definitely trying to solve. The generator. So this was the very reason why I started contributing back in 2019, because I did not want to manually write data models. I did not want to manually write these code wrappers for different protocol clients. I wanted it to be automatic or a way to use the specification for it. Now the generator takes an async API document and pairs it together with something we call templates. Now templates are in general just a placeholder that's that the data is not realized before it's paired together with the document. And the generator utilizes the parser that I mentioned before. This means that when you pair these two things, you get the output of a generated documentation, for example, as we have here, which is just a simple markdown representation of the service. At the moment, the generator supports both generating to a file, but also to a string in memory, because maybe you want to integrate the generator with an already existing tool. The template itself, we have both, we have two different kinds of rendering engines. The one I showed here is from the React rendering. And we also support Nunjux templates. Now, Nunjux is the old version, or the old rendering engine that we had, where React is a new one that solves a lot of pain points in terms of developer experience when you need to debug certain things, or stack tracing when something goes wrong with the template. And of course, not everyone uses JavaScript or want to interact with the generator through NPM, or so therefore we provide both through a GitHub action, but also Docker image. So you can use the JavaScript generator regardless of your environment. Currently, we have different kinds of official templates. We have for documentation, we have both for HTML, Markdown, and we also have the category I call skeleton code templates, which is a wrapper to the protocol libraries, which then generates simple functions that you can call instead of, or based on your AsyncAPI definition. We have both for Java Spring, CloudStream, for Nets, and Node.js for Kafka, MQTT, etc. And of course, you can create your very own local template. There's absolutely no limitations to what you want to generate. It all depends on your use case. Now, a problem that quickly occurs for skeleton code templates is the need for data models. You want to quickly access a class representing the payload that's being transferred. Now, these data models are quite difficult to generate, and it's definitely a pain point from a template or a developer that creates templates. In AsyncAPI currently, even though that, as Fran mentioned in the previous talk, allows different payload schemas or different kinds, such as, for example, Avro, behind the scenes, the parser transforms that definition to JSON schema. This means that we have a standard model to use in our tools. The problem with JSON schema is that it's good for many things relating to validating data, but it's not so great when you want to convert those validation rules, or at least complex validation rules, to definitions. This means that at the moment, each template owner has to handle this logic on their own, and it's just not maintainable in the long run. So we kind of needed a library to take over this process, or allow us to help the developers. Now, we did end up developing our very own library for this. Some of you, if you ever heard of QuickType before, it does a very similar thing. Unfortunately, that library just didn't suit the needs that we had, or the requirements we had for the library. And in the end, we decided to invest time into developing our own. And to that end, we created Modelina. And the vision with the library was that we wanted to take any type of inputs, AsyncAPI documents, JSON schema, it could be a TypeScript class, and convert them to other models. At the moment, the library is focusing on the very minimal structure of a data model. This means the properties, and be able to serialize and deserialize the models. We are thinking about how we can integrate this natively with the generator to allow templates developers to easier access this library. But it's still a work in progress and not quite sure how we can integrate it actually. We also have, for those that want code first instead of design first, we have JsyncAPI, which is a code first tool for Java that can build AsyncAPI documents directly in your code. We have a playground for people to easily play around with different or with the specification and easily get a what's it called, a visualization or a documentation directly in the browser. Now the playground actually uses the generator that I talked about earlier, and uses the HTML and Markdown template directly, or templates together with the generator to provide you with this output. We are working on something called Studio, which is a more elaborate platform where you can store multiple APIs to a user or a group or for teams. And underneath the HTML template and indirectly the playground and Studio, we have React components. Now, React components are for you to easily render UI components or your AsyncAPI document in your own tools wherever you would need them. This means that we, of course, support the React components to be used in other frameworks such as Angular, Vue, and Web components. We also want to give you the possibility of converting between AsyncAPI versions. This means that we have converters for example, for converting the 2.0 documents to 2.1, which has just been released actually this week, I think, or last week, I can't remember now. And yeah, we of course have it in both JavaScript and Go at the moment. Now, the rest of the tools that I'm going to highlight are highly work in progress and to different extents. The first one is the Discover tool. When you have multiple AsyncAPI documents and multiple applications, you want to get a visualization of how the relationship is between them. This can, for example, be to generate planned UML diagrams or mermaid diagrams to get a clear visualization of how the different applications are connected between servers and which channels they are interacting with. We are working on a gateway which can take or support any protocol and do both message validation based on your AsyncAPI documents, manipulation of the messages, etc. We also have a CLI in progress, which is going to be our main CLI for all tools, basically. So this means that you should be able to validate messages or validate the documents, manipulate the documents. It could be generating using our templates or generating models, data models. And what about if you don't want to learn about the spec, but just want a human-like interaction and get get an AsyncAPI document out of it based on the replies that you have to the bot? We also have something we call Fluffy Robot. So this is a simulation tool. This means that we pair up one or more AsyncAPI documents together with a scenario. Now, a scenario could be a specific user story you want to test throughout your system, or an end-to-end test that you want to execute. And the fluffy robot will then combine those two and execute that scenario in your system. A diff tool, if you want to know the difference between AsyncAPI documents. This could, for example, be that if the payloads are not correctly aligned or different from one another and are not compliant with each other. It can be channels that are somewhat misspelled, or it can catch different things. So basically just any discrepancies between the AsyncAPI documents. An optimizer, in case that you generate AsyncAPI documents from code or through tooling. This can mean utilizing the reusability that's in the spec itself through references and different other kinds of things. And this basically just comes back to the vision that we have with tooling. Like, we want to give the developer a seamless developer experience throughout the workflow with the specification. And we want to try and solve as many pain points as we possibly can. This means for your use case, but also from the tooling perspectives. Is there any pain points in the tools that we need to solve? And of course, almost or a lot of use cases are unique, and you want it to be able to extend the implementation or customize the very behavior of the tool to behave the way that you want. And in the end, like, collaboration and community driven, that is the very key figures for this. This also means, or come back to that, it's not just AsyncAPI that we're trying to create tooling for, but it also, as you saw with Modelina, for example, it's for JSON schema itself, trying to solve the pain point for OpenAPI for data models, because they have the very same issues with JSON schema as we have, at least the community have with the tools. And of course, this comes back to, we are community driven. There's absolutely no restrictions on which tool belong in the AsyncAPI organization. So yeah, reach out. And I hope at least that this talk maybe gave you an idea which kind of, or at least a great overview of which kind of tools we have now in progress. What we might be missing. You might have a very special use case where you would love to see a specific tool that you need. But yeah, that's actually the end of my